Right now, every developer in the tech industry is racing to build an autonomous AI agent. The promise is that these tools will act entirely on their own. We're told they will browse the web, write thousands of lines of code, and execute complex workflows without a human ever touching a keyboard. And the assumption driving all of this is that the underlying models, the brains of the operation, are getting exponentially smarter and capable of independent thought. But a few weeks ago, a massive leak of source code from a highly advanced agent called Claude Code showed us exactly what is under the hood of these systems. A research team went through all 500,000 lines of the leaked code. This diagram represents the entire codebase. It shows the actual AI making decisions is exactly 1.6%. Inside that sliver is a single while loop wrapping a call model function. The remaining 98.4%, this massive empty void, is what actually creates autonomy. A raw AI model is like a consultant sitting in a pitch-black room. It only speaks when spoken to. It can't interact with the outside world, and it has almost zero short-term memory. If you ask it to complete a multi-step task, it will instantly forget what it did in step 1 by the time it reaches 3. This visualization shows how engineers solve that. The incoming conversation history passes through a 5-layer compression pipeline. It constantly summarizes the data so the model doesn't lose context mid-task. But even with perfect memory, the model still lacks hands. It can suggest code, but cannot type it. To bridge that gap, the architecture surrounds the AI with 54 nodes representing hard-coded tools. The AI passes an instruction, and the tool does the physical execution. Of course, an AI making thousands of decisions a minute will inevitably execute a command it shouldn't. To catch those failures, a rigid barrier of 7 permission modes locks around the tools. If the AI breaks something, a robust recovery loop intercepts the error, forcing the model to try again safely. The entire operation running around the model is what makes sure its commands actually happen. An AI agent is a massive, highly traditional software operation built entirely to babysit a fragile neural network. We can see exactly how this architecture is deployed right now by looking at OpenClaw, a massive open-source personal AI assistant built by Peter Steinberger and a community of developers. In the OpenClaw documentation, they are incredibly clear. The AI model is not the product. The actual product is the gateway, a central control plane that manages all the routing, tools, and sessions. Because OpenClaw runs locally on a user's device, giving a raw AI free rein means it could easily read private emails, or worse, overwrite vital system files. This diagram illustrates their defense mechanism. The gateway routes all inbound requests into heavily walled-off zones, strict Docker sandboxes. This traps the execution tools in an isolated environment, so they cannot escape to the core operating system. The threat doesn't just come from within the computer. OpenClaw connects to platforms like Slack, meaning bad actors could message the agent to steal data. To stop this, the gateway acts as a perimeter filter, intercepting unknown senders and bouncing them back. The AI never sees the text. What feels like a seamless, highly intelligent personal assistant is entirely reliant on the structural integrity of this gateway, not the cleverness of the language model it contains. By April 2026, the transition from passive chatbots to active agents reached the global stage. At this TED conference, Peter Steinberger explained that we have crossed a point of no return. He told the audience that the lobster is loose. Autonomous agents are operating in the wild right now, and there is no putting the technology back in the box. As foundational models keep improving, their performance curves are starting to converge. When every developer can plug into a model with the same level of reasoning, the specific brand of brain you use stops being a competitive advantage, which means the current race to let the AI handle everything on its own is a dead end. Handing a massive prompt to a neural network and hoping it figures out the rest will not scale. Success in the AI market now belongs to the companies that build the best 98%, the infrastructure, guardrails, and control planes that make a model useful in the real world. The path to true autonomy isn't about training a larger neural network. It is a triumph of resilient, traditional software engineering.